In today's lecture, we are going to study the Gauss Law. Before going to the new topic, first let's review the last lecture. We studied the Coulomb's law, according to that, the force between two charged particles, the force which we call the Coulomb force, was equal to K Q1 Q2 divided by R square, where K is a constant and it's equal to 9 10 to the 9 Newton meter square Coulomb square. Q1 and Q2, they are charges, and R is the distance between these two charged particles. For example, this is Q1, Q2, and the distance between them is R. So they interact with each other with some force F, and this force is called Coulomb force. And then we also defined electric field strength. And to define electric field strength, electromagnetic field at some point, so we have to insert a test particle at that point. For example, if there is some electric field, to find the magnitude of the electric field at this point, we had to insert some test particle. Let's put it here, Q, and we had to measure the force which is acting on this particle, and let's call it F. And if we divide this force by the magnitude of its charge, so I mean the charge, then we will get the electric field strength at that point. For a charged point particle, let's say for a point particle, with a charge Q, we find out that E was equal to K Q divided by R square. We can also write this in vector form. To do so, E was equal to K Q divided by R cube multiplied R vector, since R and E are in the same direction. Now, to study the Gauss law, first we have to define the electric flux through some surface. So electric flux is denoted by phi, big phi, and this flux is equal to E multiplied ds vector. through some surface. Consider we are given an electric field which is in this direction, and if we want to find the electric flux of this field through some surface, for example this surface, we have, so in this case, E electric field strength and S, they are parallel. Let's write in this way. So the scalar multiplication, no, you have to note that here you can see the scalar multiplication of two vectors, where E is the electric field strength and S is this is a vector quantity which has a magnitude ds, the surface. However, it has also a direction which is perpendicular to the surface. Now in this case, E and S, they are collinear vectors, so the scalar multiplication of these two vectors is equal to E ds multiplied cosine the angle between them. So since they are collinear vectors, the angle between them is 0, and it's just equal to E multiplied ds. So consider a uniform field that E is constant, then the flux could be equal to, is equal to E the S, and since field is uniform, we can take E out of the integration, so it is E the S, and this gives the total area, and we will find that flux is equal to E multiplied S. Okay, let's put it right. And since F flux is a derived quantity, it has also units which is derived units, and the units of flux is Newton meter square divided by coulomb. Now let's continue our lecture with the following problem. A uniform electric field of magnitude 1.1 × 10⁴ Newton coulomb is perpendicular to a square sheet with sides 2 meters long. So sheet has a square like shape, and each side of the sheet is 2 meters long. So let's say A is 2 meters, and a uniform electric field, which means E is constant, and the field is going, for example, downward. Okay, so the magnitude of the electric field is 1.1 × 10⁴ Newton coulomb. So we have to find the electric flux F through this sheet. So how do we do that? As we said, by definition, okay, let's write in this, V is equal to E ds. Again, in this case, uh, electric field is perpendicular to the surface, so the angle between E and ds is equal to 0, so cosine 0 is 1 again, and taking into account that E is also constant, we can write E ds, and it's Es. Now let's calculate it. E is equal to 1.1 10 to the 4 Newton Coulomb. So this is the final solution. The electric flux is equal to 1.1. Okay, just a second. 1.4. Okay, this is electric field multiplied to S. The surface of the square is a square, which is equal to, okay, let me write it here, a e multiplied a square. So a square is 4. Now we can write as 4.4 10 to the 4 Newton Coulomb. Now we are going to study Gauss law. So Gauss law relates the electric flux through some closed surface to the net charge within that surface. For example, take a closed surface, for example, any surface, and consider that inside there is a charge which is Q. For simplicity, take one charge, but it doesn't necessarily mean that there should be one charge. Okay. According to the Gauss law, the flux through this closed surface, first the flux through a closed surface, we can write it as, so this circle around this notation means the closed surface. Okay, so since the our surface is closed, we have to put this circle here. EDS is equal to Q enclosed divided by epsilon 0, or let me write it, since we know K, 4 pi K Q enclosed. So this is called the Gauss law. Okay, let me write it here, that E ds is equal to 4 pi K Q enclosed. To understand Gauss law in a more detail, let's solve the following problem. The electric flux through a spherical surface is 4 10 to the 4 Newton meter square Coulomb per Coulomb. What is the net charge enclosed by the surface? So if we take any surface again, and there is a charge, okay, let's say Q enclosed. So here we also need to put enclosed. The flux is given, so it is 4 10 to the 4 Newton meter square Coulomb. So we have to find the enclosed charge, or you can just put Q. Okay, according to the Gauss law, phi is equal to, okay, this is equal to phi, okay, so this integration is calculated already. 4 pi k q enclosed. From this equation, q enclosed, or we can write enclosed, v divided by 4 pi k, so it's equal to 4 10 to the 4 4 3 14 9 10 to the 9, so it is equal to 0.5 approximately 10 to the minus 5 minus 2, so it's minus 7 coulomb. So the next problem which we are going to solve is related to Gauss law again. Now a point charge q is located at the center of a cube whose sides are of length a. If there are no other charges in this system, what is the electric flux through one face of the cube? So this is cube, okay, and inside there is a charge, let's say q. So we have to find a flux through one side only, okay, let's say this side, okay, on the right side. We are going to find the flux through this side. It is very easy. So first let's find the total flux. The total flux phi is equal to closed integral E ds. According to the Gauss law, it's equal to 4 pi k q enclosed, right? So since q enclosed is equal to q, I can write it q only, and this is the total flux. To find the flux through one side only, you need to know how many sides are there. There are 6 sides, right? Of Q. And so since this Q is located at the center of the cube, the flux which is passing through each side is equal to each other. So phi 1 is equal to phi 2 is equal to so on, and they are all equal, phi 6. Then adding them together will give us the total flux. Since flux is scalar quantity, it is associative. So 6 phi 1 is equal to phi. From this we can find that phi 1 is equal to phi divided by 6, which is equal to 2 pi k q divided by 3. So the solution to this problem is flux through one side is 2 pi kq divided by 3. Now we are going to look at the following problem. A very long thin wire has a uniform linear charge density of 50 microcoulomb divided by meters. What is the electric field at a distance 2 centimeters from the wire? So, okay, there is a wire, okay, and it has a charge density, let's denote it by T, which is equal to 50. Okay, let me write it in this side. Okay, tau is equal to 50 microcoulomb divided by meters, and from 2 meters away, let's say at this point, so distance, this, let's call it d, is equal to 2 centimeters. We have to find the electric field. How do we do that? Again, we will use the Gauss law. According to that, E ds is equal to 4 pi k q enclosed. Now, you see there is an integral over some closed surface. We can use this Gauss law when there is a great symmetry. So we have to choose our enclosed surface in such a way that at this surface E must be constant. So first, step 1, choose surface where choose surface such that E should be constant on it. So in this case only, our integration will be easy to calculate, and we can find electric field easily. So we can take this cylindrical shape, okay. So at each point, at these points here, there, or there, on the surface of the cylinder, E is constant. So this is a very nice choice, okay. Now, what is the enclosed charge in this case? So we have to take the charge inside the cylinder. So this is, so Okay, this is the one which is inside the cylinder. Since the linear charge density is tau, Q is equal to, if I multiply it to L, it will give us Q. Okay, so this is the enclosed charge. Then we can write, first of all, since E is constant at that surface. So, okay, now step 2, let's calculate the total flux, okay? Step 2, calculate the total flux. There are 3 sides. Okay, let's call this side 1. And there is also a surface which is side 2. Let's call it side 2. And so E is going to the outward, okay, up or downward. Actually, it's perpendicular to the wire in every place. So the flux phi1 and also phi2 is equal to 0, since E ds at these places E and S is perpendicular to each other, so it's equal to 0. So the phi 3, which is the flux through the cylindrical side, in this case is equal to E ds. In this case, E and ds, they are parallel, and on the surface E is constant, so it is E multiplied S. S is the cylindrical side, so it's equal to 2 pi r, radius of the cylinder. So radius of the cylinder, we chose it in such a way that the radius of the cylinder should be equal to d. So 2 pi d multiplied the length of the cylinder, so it is L, right? L. So the total flux is the sum, so it is only phi 3, which is equal to 2 pi dl, or ld, let's write ld, multiplied E. And according to the Gauss law, it is equal to 4 pi k q. And q is equal to tau L. Look at this. I can put here tau L. Both sides there are L, they will cancel. And we can find E, which is equal to 2 pi will also cancel, 2k tau divided by d, and it is equal to 2 multiplied 9, 10 to the 9, tau is equal to 50, 10 to the minus 6, divided by d, 2, 10 to the minus 2. So it is equal to, well, 4.5, 10 to the 9 minus 6, it's 3, plus 2 and plus 2. So it is 3, 5, and 7 Newton meter square. So you see, using Gauss law, it simplifies your calculation, and If there is a symmetry, then you can use and find E easily. But in general, it's very difficult and it's not uh, always possible to apply this Gauss law. However, if it is plane, for example, infinitely long plane, white plane, then again you can apply Gauss law. And it's very useful and it's a very good tool to determine the electric field at a given point.